Today we will see the fourth chapter, that's the laws of motion. Okay. So before going into the laws of motion, so that means we will see this, we will study about this chapter, the series of lectures. Okay. So before we are going to the laws of motion, there's a certain, okay, when I say a motion, what do we mean by motion? It's a movement. Okay. The position, if a position of the particle changes with time, then you call the object is in motion. Okay. So now when you deal with the objects in motion, okay, and that part of physics, okay, understand? So any part, with time, if the position of the object is going to change, that when you try to understand that problem, okay, and that branch of physics is called as a mechanics. Okay, what is mechanics? Mechanics is the physics which deals with the objects which are in motion, not necessarily motion. It can be in rest also. How? For example, uniform motion. Okay, this is something is moving in a constant velocity. You will see it is moving with the velocity. Now, if you also move with a constant velocity along with it, the same direction, will you see that object moving? For example, if there is a car, we are driving the car or a bus at a constant velocity. Of course, for the people in the road, you will see the car is moving, correct? So, your neighboring passenger who is sitting, is he at rest for you or moving? Is at rest. Okay, so everything is relative. So, in mechanics, whatever, when we are dealing with a motion, sometimes because you are also moving, because of your own motion, or your own behavior in time, we can reflect the other body is in rest or in motion. Okay, so for example, I told you, if you are on Earth, if there are two spots on Earth, okay, suppose two mountains on Earth, Himalaya, okay, will it be rest or it's moving? Rest, but the rest is with respect to you only. Suppose if you are in moon, it will be moving. You got it? So of course, so that's what your rest, emotion. When you say emotion, important thing is with respect to what? With respect to me. Often it's me because I am going to study the system. With respect to me, whether it is in motion or it is in rest. Okay, so this is what. So that's why in mechanics, it's not only we deal about the body which is in motion. We deal about the body which is at rest, which is not moving. Okay, because something which is not moving for you is not necessarily it's not moving for third person. For that person can be moving because you both will have a different velocities. Okay, so therefore when you deal mechanics, you deal both the objects which are moving and the which are stationary also. Okay, so then the mechanics can be mechanics will be can be divided into two things. Am I right? So that is one when it is in motion, another one is stationary. Am I right? This is one. So you have to deal about both. Okay, so we need to know what will happen if a body is at rest in front of you, what is going to happen if a body is moving in front of you. So we have to study about both the objects. So that's why we'll have a mechanism motion when the body is in motion as well as body is in stationary. Okay, so when it's motion, you call that as kinetics. Kinetics, whatever. Kinetics, you know, and this one as statics. Okay? Yeah. So when you are seeing if a body, you are trying to study the body which is in motion, that is called as a kinetics. When you want to study the object which is not in motion, stationary, that's what statics. Okay, so that's what your okay, and it's okay. There's an important point is see statics. Certain object which is at rest. When it will be at rest, you will see later on. When no force acts. Okay, when no force acts on it, object will be at rest. Okay, we have seen that whenever you give an object, there's acceleration is happening. Okay, it can be also at rest if equal forces are acting on all directions. Okay, see, for example, if I hold the ball, pen, it's at rest here because there's a gravitational force which is pulling it down, and I am giving an upward thrust. So that's what they both are balancing here. Therefore, the pen is at rest. If an upward thrust is heavier, okay, if I give more thrust, then I can move the pen up. If the pen become too heavy, I can't hold it. Then my hand will move down. Okay, so there what happened. So what going to matter is the resultant force. Okay, so even when we say about statics, why we want to study statistics? Statics is because statics depends upon the body can be static when the equal forces or the resultant force will be zero. There's a net combination of forces, and when the resultant combination of forces become zero, then the body remains static. Okay, that's what you need to know about the kinetics and statics. Okay, so now when we see kinetics, so if you remember the last chapter, we studied about the kinetics. You remember we studied about the motion of the objects. Yes, projectile motion, motion in a plane, rectilinear motion, motion in a plane, 2 dimension, circular motion, projectile motion. These are what? They are all moving, right? That's one. So that's a kinetic motion. So that's the examples of kinetics. Okay. Now, when we are discussing about that, when we saw about the equations of motion, when we saw about the trajectory of the particle, what is the quantity we used? We used initial velocity and some final velocity. We said initial velocity we gave, okay, and then certain acceleration. Suppose in terms of projectile motion, you are giving initial velocity and there is acceleration due to gravity. It makes a parabolic path. Correct? You saw all those things. There, what was the quantity we were using? Velocity, displacement, acceleration, time and all. Okay. So now, but is that complete? That's not complete. Okay, you are telling you have left set a projectile at a certain velocity. Now you are asking me where the projectile will land. It make a parabolic path and land. Okay, and if you see, now what causes your initial velocity? Force. We never included that. And that is important. The reason is, if I want to throw an iron ball, or a plastic ball, or a cricket ball, or a tennis ball over a certain same distance, I need to give different forces. Okay. If a cricket ball, what my earlier equation of motion said is, irrespective of what the ball is, whether it's a cricket ball or a tennis ball, iron ball, given the initial velocity, it doesn't matter. If your velocity is same, if all the initial velocity you are giving, okay, for an iron ball or a cricket ball or a plastic ball, if you try to maintain with no air friction, remove the air friction, if you give that initial velocity, all irrespective of what that ball is made up of, all the ball will reach up the same point, the range, the horizontal range, the time of flight, everything will be same. That's why if you see in this equation of motion, there is no mass term coming into the equation. Am I right? There was no mass. The equation is independent of mass. Okay. But to give a same velocity, if I want to throw an iron ball with the same velocity, or a plastic ball with the same velocity, or a cricket ball with the same velocity, is that the same force I have to use? Can I kick an iron ball like I can kick a football ball? Football? No, right? Okay. If I kick an iron ball, my leg is going to my leg is going to break off. Okay. So of course, what happened? So to give the same velocity, you need to have a different forces. Okay, so in the earlier part of the lecture, what we saw about the trajectory of a projectile and all, it is not even complete. It gives you the trajectory, all the parameters it gives you. But now, what you think, one of the important quantity in the whole calculation is the initial velocity. Remember, right? Depending upon the magnitude of the initial velocity and direction of the initial velocity, the projectile reaches everywhere. Okay, so that's an important quantity. Now the question is, how do you how do that body attains its initial velocity? What is the necessary thing for the body to attain its initial velocity? When we question about that, then it comes the force you have to apply. What is the force you are giving? Okay. So then, when we deal about the kinetics, the two-way we can see. So what I am going to two-way is, so then kinetics can be further divided into two things. What I call is kinematics. In kinematics, you don't bother about the force or anything. In kinematics, we don't need the mass of it. We don't need, what we know is we use only velocity. If you give me your initial velocity, let us, what are the symbol we used? U. Am I right? If you give me U and any acceleration acting, maybe acceleration due to gravity or everything. So, and then you can find out what is the time of flight, all the quantities we can find out. So that's what you call as your kinematics. And the next one is, kinetics is divided into another one is a dynamics. In dynamics is what? Now you put up the question. To attain that initial velocity, what is the necessary condition? What is the necessary thing? If I want to attain the velocity, initial velocity u for iron ball or a cricket ball or tennis ball, I need something, correct? So that's what you call as a force. Where you deal with the force, mass, other quantities. This when you deal with the force, mass and everything, and this comes out to be your dynamics. Okay, so, and this is what the more picture means, more realistic is the dynamics. Kinetics is only gives you a trajectory and all those things. The dynamics is the one which is going to decide what should be the initial value for all those things, initial velocity and everything, and then you can decide your trajectory and other quantities. So for dynamics is the primary thing. What is the force you are giving? If there are many forces acting, not a single force, many forces are acting. So what will be the net effect of that force on the body? Okay, and that we never dealt those things in our kinematics, where earlier we were discussing. Okay, so this is what we did about the kinematics and the dynamics. Okay, let me read the what are the quantity given in dynamics. Okay, kinematics, what happened? Okay, kinematics deals with the many things like what happened, your distance, displacement, speed, velocity, acceleration. Because these are the quantities you require to find out are the quantity, like what we saw in the earlier chapter. Time of flight, range, what is the maximum height the projectile have reached, or in a circular motion. Okay, what should be the radius, what is the angular frequency. Remember all those things we calculated. Angular velocity we calculated. All those things. This is what we call as kinematics. Okay. In dynamics, we are not going to just see about, for what happened for kinematics, one important quantity is initial velocity and the associated acceleration. Some acceleration which is acting on the body. That's going to decide about your final motion of the trajectory or other quantities, whatever you're doing. So here only we found out the equation of motion. So remember? So we have to write down this is equation of motion. That we did. Okay. On the other hand, in dynamics, we are going to deal by study. We have to find out the initial velocity and everything. So what are the quantities going to decide about that? Force, mass, energy. Am I right? If I drop it, and that's going to hit the ground with a certain, I can take how long it will take, potential energy in the, okay, because I know when I drop it, I know there's going, initial velocity is 0, the gravity is acting, so it's pulling up and we get the final velocity and all right? So now the question comes is, so now what is the force which is giving the force which is acting on the body? Okay, so those things, potential energy, mgh, which will be eventually converted into the kinetic energy as we go down. You've done all those things at 10th standard, right? 9th you did. Okay, fine. So this is what dynamics. In dynamics, what happened? Think examples what they given. Momentum. We'll come to momentum. I will tell you the momentum is important quantity. Force, you know momentum. You read about momentum, right?
In the first law of motion.
Correct. Okay. Yeah, you done the momentum. Yes, correct. Force, energy, power, these all are basically dynamics. This all required. This is required in addition to kinematics. Okay, so and now okay. So now this is what we are going to see in the mechanics, and what we will particularly in this chapter, the laws of motion. What we are going to see is what is going to happen in the dynamics part. Okay, so which is going to give what is going to be the velocity, which is provide. Okay, that's what we are going to see it in the dynamics. Okay. After defining what was we saw dynamics and the associated kinematics. Okay, so we can do it, but what we are as a whole, what you are going to deal is what the motion. Okay, now when I look at the motion itself, there are different types of motion we saw in the earlier class also, right? One is a rectilinear, or I will call it a linear motion. Simply, I will call it a linear motion. So, what was that? So, let me call this as a linear motion. Okay. So, when will there be a linear motion?
In a straight line.
Correct, straight line. Okay. So, what happened? So, when an object, or suppose, for example, when will a ball, when you are kicking a ball, or in a carom board, you are striking a striker, right? The striker motion will be linear. Okay, so what causes its linear? Force. There's an acceleration, correct? The force going, of course, we're giving a force, and there's an acceleration. So now you tell me what will be the direction of the acceleration, and what will be the direction of the velocity?
The direction of velocity will be in the same direction as the force.
Force, yes, exactly, correct. So now, is that always?
Yes, unless another force is applied on it.
No, for example, and strike a coin is moving like this, a ball is moving like this.
Okay.
If another ball come and hit like this here, will that velocity, it will make a path like this, right? So what happened? Your ball is moving like this. Suppose if another ball come and hit it, then it makes a round like this, right? Okay. So there, of course, it's not going to be. So this is not a linear motion. So for a linear motion, there are two things. One is, so when will we say linear motion is, suppose, first thing is, when the object in rest, okay, when there is rest, initial velocity, rest means what? Initial velocity is zero, correct? Now when we apply an acceleration, when the body is getting acceleration, okay, it's going to attain a velocity, okay, both acceleration and velocity will be in the same direction. Okay, and now comes what will happen, not means stay moving. That means initial velocity is not zero. Then what happens?
Velocity will be in a different direction, but acceleration will be in the same direction.
Will in the direction of acceleration, will there be a component of velocity?
We should know because it's.
There will be velocity, we'll come to that. Okay. So now, okay, when we are dealing about a linear motion, so if there is already a motion, and if we give an acceleration, and even after that, the motion is supposed to be linear, what should be the acceleration?
Zero.
No, suppose I am giving acceleration. What should be the direction of the acceleration?
In the same direction of the.
Exactly. If there is a moving, if the initial velocity is not zero, that means what? There is a u. Am I right? We are having an initial velocity u. Okay. And then the linear motion. For the motion to be linear, a and u should be in the same direction. So this sort, whenever this happens, your motion will be linear. Okay. So that's why I said, when the ball is moving, when you give a perpendicular force, okay, that won't be linear. Because the body is not more linear, it's going to make a change. Okay, so there will be direction, velocity component comes along the direction of the acceleration, so which diverts the ball and deviates from linear. Okay, so for a linear motion, if the body is at rest, doesn't matter. Wherever the acceleration you are giving, the velocity also will be in the same direction. If the body is moving, and if a body is moving, then the motion will be linear only if the acceleration is also along the direction of the velocity. That's a linear motion. And next thing we saw, you remember what was the next thing we saw? That's one minute.
In that thing,
Ah.
if it can also be in linear if it's the opposite direction of the motion.
Yes.
Huh.
Yeah. You put an opposite force, negative. That also is possible. Yeah, right. Suppose there is an repulsive force. Something is acting, pushing against it. Then also it slowly goes and stops. This is a linear motion. Okay. Yes, right. So for linear motion, it is not necessarily the acceleration should be along the. It can be either along or opposite. Good. Okay. In both the cases, your motion will be linear. Okay. That's good. Now, this is a linear motion. Now, we will see about the second one is circular motion. You remember for circular motion, there's one necessary requirement is the acceleration. Right? That should be perpendicular to the velocity, speed. Am I right? So, can there be circular motion if initial velocity is 0? No, right? There has to be initial velocity and there has to be acceleration. Means what happened? The stone, when you're tying a stone, there has to be initial velocity given to the stone and there has to be a string which gives a force towards the center. Therefore, there's acceleration. That's why it makes a circular orbit. Am I right? So, in this case, what happened? For circular motion, we have only one thing. The initial velocity should be non-zero. Am I right? So, for a circular motion to happen, initial velocity should not be equal to 0 and acceleration should be perpendicular to your initial velocity. Okay, we saw that. That's what your circular motion. And then we saw another one motion also. Remember? What was that? Parabolic motion. Or that was what you think? Projectile motion. Right? Let me write it as a parabolic motion. The parabolic motion, what happens? So there are three things you see. First one is when the acceleration is along the direction of velocity. When the acceleration is perpendicular direction of velocity, it causes circular. When your acceleration is neither along nor perpendicular, that's what your stone is, right? Where projectile motion is that, right? What happened? You throw a stone with a velocity here and the gravity is acting like this. Are they both perpendicular or aligned here? No. Okay. That time what will be the trajectory? Is a parabolic path. Okay. So for a parabolic motion, what do we have? Means initial velocity and the acceleration are not in the same direction. Initial velocity and acceleration are not in same direction. Okay. This is not just this, there are many more motions you have. As you go in higher studies, you will see there's a helical motions also happens. When you deal with a charged particle, whenever a charged particle enters a magnetic field, magnetism, the charged particles start moving in helical motion, spiral. Okay. So these are different motions. Okay. For in the beginning, these are very main three motions. Linear, circular, parabolic. Okay. And there can be a combination of all these motions also. Okay, when you have many forces acting, there can be combinations of all these motions. It can be very complicated also. There are complicated motions also. Okay, so most of your day-to-day life, whatever we are going to see, they all can be confined to these three types of motions. Okay, maybe a linear motion, circular motion, or a parabolic motion. Okay, when the randomly moving particle, you can't do that. Okay, that's why I mentioned the line. If not random, motions in real life may be understood separately as linear, circular, or oscillatory, etc. Oscillatory motion. So now in this all this motion, there are only two important quantities. Do you remember what are the two important quantities? That's what we dealt with. Initial velocity and the acceleration. Okay, there also, because when you see, remember when you say initial velocity, it means a direction also. Okay, so if you remember the projectile motion, if you remember what we did in the projectile motion, we had the projectile. When we throw it initial velocity, we can exactly trace back where the stone goes up with the equations of motion, parabolic. Okay, so and we used only one thing. Am I right? Initial velocity. Okay, isn't that enough?
And then the gravitational.
Yes, gravitation also. There's a gravitational force acting downwards. That also, because the projectile is going to be different when you throw it on moon. When you on Earth, the gravity is going to be different. Gravitational force, acceleration to gravity is going to be different. Okay, so only your initial velocity and the acceleration acting, that decides your entire motion. That's what we are dealing as a linear motion, circular motion. When initial velocity and acceleration is perpendicular, it causes circular motion. When they are not perpendicular, they cause a projectile motion. Sorry, parabolic motion. Okay, so and there can other combination of motions also. So for a different initial velocity directions and the acceleration directions. Okay, so fine. But that when you go into space, as I said, helical is when you do it in the not in a helical is not in 2 dimension. Helical in 3 dimension. Okay, so that's what you will study in the classes. Okay, okay. So what we did till now, we found out we
Types of
motion we saw before the now what we in the laws of motion what you are going to deal is the dynamics. Okay, the equation of motion gives you the kinematics. So what you are going to see is the dynamics. So the for dynamics, okay, what we put up what are different types of acceleration, how the motion changes. That's what we saw. Now for that acceleration to happen, you need to have a force. Am I right? Whether there is a force, well, actually, I should now mention something. Yeah, so the moment when you are dealing with the kinematics, one of the important quantity which is going to decide your most of your the trajectory or your time of flight or any quantity what we saw is the important quantity is the initial velocity u and the acceleration acting. Am I right? Now, so now this is when I go to speak about this is for the kinematics I am doing. When I going from kinematics to going to deal with the dynamics. Okay, so then means when I say dynamics, what I am saying is what is the force I have to apply? What should be the energy of the body so that it can move? What should be initial energy? What is the force I have to apply? Okay, so all when I do all those things, this quantity is not a sufficient quantity. It's a quantity, necessary quantity, but it's not a sufficient quantity. Why I'm saying is, that's why I said, if I want to kick a football with the same velocity or an iron ball with the same velocity, it's not the same force I have to use. Okay, so what matters is, so even though if you want to give a initial velocity u to a body, if you want to give a initial velocity u to a body, and the body of different masses needs different force to attain the initial velocity. Okay, on the other hand, what I am saying is if I throw if I want to throw over a certain distance, if I want to throw a iron ball or a plastic ball, the force has to be different. Am I right? So then what matters is not the initial velocity. Only this velocity is not the complete quantity. Okay, then the quantity which going to decide the amount of force I have to apply is called as a momentum. Okay, do you know the symbol of momentum what to use? P. Momentum is mass into velocity. Okay, so now what happened? I multiply the mass of the body also with the velocity. Now this is the right quantity. What should be the momentum? The iron ball should be thrown. So what should the momentum should be given to the iron ball initially? That makes it to reach certain range, horizontal range. What is the momentum the body should have or a plastic ball should have initially? That will make it to reach up to one. Okay, so what is going to have, what important quantity is the momentum. Okay, so now you go back to the period of Aristotle. So that's what 384 to 322. We were not even knowing that Earth is spinning around the sun. It was that volt. Okay, so we are going to that period. And now you don't know Newton, you don't know anyone, and you are the great philosopher of the period. And if you want to devise the motion, okay, so what you do it from your day-to-day living only, correct? So you roll a ball. Will the ball keep rolling forever? It stops sometime, right? So now, what will be immediate intuition? If you want to maintain the ball rolling forever, so what should happen? You should keep force. Okay, so the Aristotle, what he thought is, for any constant uniform motion to be there, you have to keep applying force. A force is required to maintain a uniform motion. Okay, so this is a fallacy which was solved by Newton later on. Okay, because he used Galileo. Galileo was given, proposed it, and Newton used it to frame his laws. Okay, so that's what is the Aristotle fallacy. Aristotle stated that during this period is this. An external force is required to keep a body in uniform motion. Because that's a day to day. Because practically, if Newton wouldn't have said you this first law, which you was read it earlier, okay, you know when you see it only on the earth, when you see anything you roll, it will stop. Okay, so and that's why Aristotle thought for any motion to be uniform, you need to have a constant velocity. For example, a chariot. When you want to run a chariot, okay, you run a chariot, you can't leave the horse and go off. Chariot is not going to run for the uniform motion. You need the horse to pull the chariot always. Okay, so it needs a force, constant force to maintain the uniform velocity. So this is what Aristotle thought. Okay, but that is not correct. There was some problem. The fallacy, the misconception in Aristotle theory was first perceived by Galileo. Galileo only found out this probably the frictional forces, the viscous forces, what they call viscous forces, the frictional forces. If you remove, suppose if you are not having these frictional forces, this question is that you got it, na? So Aristotle said, for practically, when you want to roll a ball continuously, you have to keep kicking the ball, give the force, so you can move in a uniform motion. Now Galileo put a question: is that always true? Suppose you don't have that frictional force on the ground, or suppose the frictional force on the air when you throw a ball or something is flying. There's no friction. Well, the book that I give example is a paper plane. Throw a paper plane, it lands. There's a friction. Okay. Suppose when the friction force is not there in the air, when you give initial velocity, is it necessary to give a force always? That's the question. You got it? So when you go back to that period, these are all what happened, the philosophically challenging ideas. Okay, because you live with the friction. Now you say, okay, what happens if there is no friction? So that's what the philosophy comes. Okay, so Aristotle, he never able to he didn't separate out the friction. When Aristotle put up his theory, then only Galileo can think up. Though it is a fallacy. Why it is important is because of the Aristotle's fallacy, Galileo has to ask a question. Suppose, okay, he is right, because Aristotle is not wrong. When you have these frictional forces, of course, you need to have a constant force to maintain uniform acceleration. Now, Galileo thought is, if you don't have this frictional forces, in that case, do you need to have this continuous force? Okay, so that's what your Galilean is. Yeah, the correct Aristotle's fallacy was first correct explanation to Aristotle's fallacy was first given by Galileo, which was later used by Newton. Okay, and remember the period. The noting down the period is important. Aristotle given in 384 to 322 BC, and Galileo belongs to 1564 to 1642. What AD after whatever now we call it is the diff period. This other one is the AD. Okay, so that is the period. So how many years around? Around 1800 years later. For 1800 years, people were living in the fallacy of Aristotle. You got it? So that's how the period takes, science takes so much of time to evolve. Okay, and then once Galileo put up his idea, then Newton immediately caught, and Newton belongs to a period 1643 to 1727. He just followed Galileo. Galileo's period is 1642. Newton started with 1643. So immediately Newton caught up that idea and corrected the Aristotle's, and corrected the Aristotle fallacy and derived the equations of law of motion. 3 laws of motion. Okay. So that was an interesting thing. So what he says is, and formulated laws of motion. Galileo showed that all objects stop moving because of some resistive or opposing forces like friction, viscous drag. Okay, suppose a boat is, you give a push of a boat, the boat will go and stop sometime. Boat is not going to continuously move on. The reason is because there is a viscosity. Viscosity is again a frictional force which acts in the water. You read about viscosity? No. Viscosity is a force which is acting on the, is again a frictional force on the water surface. Okay, that's what we call viscous force. Okay, so this, when you remove all those forces, then it's going to, question is, will it remain? Will it, can it move constantly? So, okay, so thus in reality, for an uninterrupted motion of a body, an additional external force is required for overcoming these opposing forces. You got it? So, for uninterrupted motion, so what the force you need is, the force is actually required to oppose this oppose resistive forces. Okay, maybe a friction or viscous, whatever, but that will need a force. Otherwise, if there's no friction thing, you don't need any force. And that's what realized by Newton. And then he derived the Newton's laws of motion.